Good evening, all. Am I audible?
Yes, ma'am.
Okay. So today we are going to start with revision of unit number 3, and that is of set theory. So let us start with the definition of set. What is meaning of set? So set is a collection of objects of any sort or of any kind. So in short, we can say that collection of objects of similar type is called as set. So for that we can consider example of set of all books. So here there is only one category and that category is book. Multiple objects are there but all those objects belongs to same category. That's why this is called as set. Also we can consider bouquet of flowers. So again in that flower multiple flowers will be there. In that bouquet multiple flowers will be there and again all those flowers belongs to one category and that is of bouquet. That's why this is called as set. So again, there are two different terms. What is the member of set and what we can say that belongs to concept. So any object belong to a set is called as member or element of that set. A set is said to be well defined if it is possible to determine by means of certain rules whether any given object is member of that set or not. So first of all, we have to see what is belongs to one set. So we can say that any object belong to a set, then that object is called as member or element of that set. So again, a set is called as well-defined set. Why this one is called as well-defined set? Because it is possible to determine whether a particular object belongs to that set or not. That's why that is called as well-defined set. So again, there are certain rules are there to represent set and their members. So capital letters always used to denote a set and lowercase letters are used to denote elements or members of that set. So this is very important point. Whenever you will say, you will see any capital letter. So that letter means what? It represents set. And if there is any lowercase letter, then it represents its element or member. So again, how we can represent whether any particular element belongs to that set or not? For that, there is one symbol that is called as belongs to symbol. If a element P belongs to set A, then we can represent it as P belongs to A. So this is called as belongs to symbol. So how we can read it? P is an element of set A or P belongs to set A. Or in third way, we can write P is in A. So P belongs to A. For this one, three meanings are here for this symbol belongs to. First one, P is an element of set A. Second, P belongs to set A. And third one, P is in A. Meaning of all these three sentences is same. So how we can represent belongs to, that is given here. So again, if there is any another object Q which does not belong to set A, then how we can express it? Q, this is symbol to represent that particular object does not belong to that set. So Q does not belong to A. In this way, we can read it. Or another way, Q is not member of A. Or Q is not in A. So in this way we can represent if any particular object does not belong to that set. So again we can say that this is negation of Q is in A. If Q does not belong to A, this is equivalent to negation of Q belongs to A. So that is given here. Negation of Q belongs to A. This is equal to Q does not belong to A. So this is concept of set. membership and how we can represent it. So, have you understood this initial part? Hello? Have you understood this much?
Yes, ma'am. Yes, ma'am.
Now, next one example is given. Here, set S is consist of three objects A. So again, we can say that one, this is member of set S, 3 is also member, and A is also member of set S. So how we can represent it? 1 belongs to S, 3 belongs to S, and A belongs to S. But if you consider any another object 2 is not present here. So we can represent this one as 2 does not belongs to S. So that's why here we have taken the symbol of does not belong to. Okay. Again, the we can define the set as a finite set or infinite set. So the number of distinct elements present in set, they may be finite or infinite. A set is a finite if it consists of finite number of distinguishable elements. Otherwise, set is infinite. This what if your set is consist of finite number of elements, then that is called as finite set. And if set is consist of infinite number of elements, then that is called as infinite set. So again, here one example is given, set S, which is consist of elements A. A is the first element. Second element is itself a set, and that is consist of elements 1, 2. So how we can read this? Set 1, 2. Third one is element P, and last one set Q. Okay. So here in this set, again there are two different sets, set 1, 2 and set Q. So there are total 4 elements, 1, 2, 3, 4. So here set Q is an element of set S because this set Q is present in this set S. So we can say that set Q is the element of set S, and the element Q, which is element of set Q but not member of S. Yes, that is correct, because if you consider set Q, then set Q is member of set S. But if you consider only Q, Q is member of this particular set, set Q. But Q is not member of set S, because here we have not written anywhere only Q as an element of set S. That's why Q is member of this set Q but not member of this set S. So this concept is very important. You should understood it. So these are some basic terms related to set. Now next part is very important, that is inclusion and equality of set. So again some terms are given. So what is inclusion or what is the concept of subset, that is given here. So let A and B be any two sets if every element of set A is an element of set B, then A is called as subset of B, or A is said to be included in B, or B includes A. So meaning of these three terms is same. If there are two different sets A and B, and if every element of set A belongs to set B, then A is called as subset of B, because all the elements of A are present in B. That's why A is subset of B. Or we can say that A is included in B. Or in third way, we can say B includes A. Meaning of all these three terminologies is same. So how we can write this symbolically? So first we can denote this subset concept by A is subset of B. So this is the symbol for subset, or equivalently we can write B includes A. B includes A. So this is the symbol for inclusion. So just keep in your mind, this is for subset and this is for inclusion, and meaning of these two is same. So again, how we can represent it? A is subset of B. This is equivalent to, for any element X, if X belongs to A, then X belongs to B. And this is equivalent to B includes A. So meaning of all these terms is same. A belongs to A is subset of B means what? If there is any particular element X, then if X belongs to A, then definitely X belongs to B. Why? Because we have seen that A is subset of B if and only if all the elements of A are present in B. From that, we have written in here by taking one particular object X. Now, again, here one example is given. Four sets are there, A, B, C, D, and each and every set is having its own set of objects. So from that, we have to define which one is subset of another set. So if we consider B, set B is subset of set A. So that is written here, B is subset of A. So why? Because all the elements of set B are in set A. Check here. Set B is consist of two elements, 1 and 2, and all these two elements are present in set A. So we can say here B is subset of A. So likewise, again we can say that C is subset of A. Why? Because set C is consist of 1 and 3, and those elements are present in set A. So again, D is subset of set A as well as of set C, because these consist of just one element 3, and that element is present in both the sets, that is in A as well as in C. So in this way we can recognize which one is subset of another set. So here one set is given, set A, and that is consist of three elements. First element is set 1, second one is 2, and third one is 3. Then we can say that set 1 belongs to A. Yes, this is correct because set 1 is a member of set A. Again, if you consider set 1 and 2, this is subset of set A because these two elements, set 1 and 2, those are present in set A. So, correct. We can write it. Again, set of set 1, this is subset of A. Now check it. Yes. Set 1 is present in set A. That's why set of set 1 is subset of A. We can write it. Again, 2 is subset of A. Yes, this is also correct. And next one, set 2 comma 3, this is subset of A. So if Hello. So do you have any doubt regarding this subset concept? If do you have hello? Do you have any doubt? Okay. Now next term is a equality. So when we can say that two sets are equal. So here we have considered two sets A and B. So these two sets are said to be equal if and only if A is subset of B and B is subset of A. So how we can represent this equality? A equals to B. This is equivalent to if A is subset of B and B is subset of A. And so if both A and B are having same elements, then we can say that A and B are equal. So here that is given A is equals to B. This is equivalent to for any element X belongs to A if and only if X belongs to B. So here some examples are given. From that we can check whether two sets are equal or not. So check here first example, set is consist of 1, 2, 4 and second set is consist of 1, 2, 2, 4. So again every element of set 1 is present in set 2. That's why these two sets are equal. What is meaning of this 1, 2, 2, 4? Again 2 will be counted once. That's why this is equals to 1, 2, 4 only. If you consider second set 1, 4, 2, this is equals to set 1, 2, 4. Just sequence of elements has changed. Otherwise elements are same. That's why these two sets are equal. Now consider third term. Here two sets P and Q. First set, that is set P, is consist of set 1, 2 and second element is 4. If you consider set Q, it is consist of 1, 2, 4. So these two sets are not equal. Why? Because here in this set P, only two elements are present. Out of one is set itself, that is set 1, 2, and second element is 4. But if you observe set Q is consist of three elements 1, 2, 4. That's why these two sets are not equal. Again, fourth example, set of set 1. This is not equals to set 1. Why? Because set of set 1. This what? This set 1 is a member of this outer set. But if you consider set 1, here 1 belongs to this set 1 and here set 1 belongs to this particular set of set 1. That's why these two terms are not equal. Again, fourth one is given as if A, this is equals to for any element x such that x into x minus 1 is equals to 0 and b is equals to 0 comma 1. So how we can check whether these two sets are equal or not? First we take value of x as 0. So check here 0 for 0 into 0 minus 1. Again this is equals to 0 only. If you consider value of x as 1, so put that value here 1 into 1 minus 1 and 1 minus 1 is 0. So 0 into 1 again it is 0. Means what? These two sets are equal. That's why A is equals to B. So this is the concept of equality of sets. If A and B are having same elements, then we can say that both the sets are equal. Now, next term is proper subset. So this is very important term, proper subset. A set A is called as proper subset of B if A is subset of B and A is not equals to B. So these are two conditions requires to be a proper subset. First one, A should be subset of B and A should not equals to B. Then only we can say that A is proper subset of B. And how we can represent that? Here A is subset of B. So this is the symbol for subset. So here we can represent that as A is subset of B. This is equivalent to A is subset of A is proper subset of B. This can be equals to A is subset of B and A not equals to B. So this is a symbol for proper subset, or this is also called as proper inclusion. So again, this proper inclusion is not a reflexive, however, it is transitive. Means what? A is proper subset of A. This is not true because what we have written for proper subset, there are two different conditions. A should be subset of B and A should not equals to B. But if you consider whether it is satisfying the reflexive property or not, what is meaning of reflexive? It will deal like A is proper subset of A. Now check whether this one is possible. Not possible because it should satisfy two conditions. First one is A is subset of A and second one A is not equals to A. First condition is true, that is A is subset of A. But second one, A is not equals to A. This is not true. That's why proper subset does not satisfy property of reflexive. But it satisfies transitive property. And that is written here. A is subset of B and B is subset of C. This is equivalent to A is subset of A is proper subset of C. So just keep in mind that inclusion satisfies both the properties, that is reflexive as well as transitive, but a proper subset satisfies only one property and that is reflexive property. Now next term is universal set. So a set is called as universal set if it includes every set under discussion. Means what? It consists of all the sets, then it is called as universal set. And that is denoted by E, symbol E. So how we can represent this one? E, this is equals to for any element x such that p of x or negation of p of x. So here that p of x means what? Predicate of x. Predicate means what? Condition that applied on x. So a set is called as universal set if it includes every set under discussion. That is a universal set. Next term is empty set or null set. A set which does not contain any element that is called as empty set. Empty means what? That does not contain anything. So set which does not contain any element is called as empty set or null set, and that empty set is represented by this symbol phi. So phi, this is subset of A, because for any element x, x belongs to phi. This tends to x belongs to A. So how we can represent this phi? So phi means what? Empty set. So that empty set can be represented as for any element x such that p of x and negation of p of x. So is it possible whether that element x is present in that set and negation of x that is also present in set, that particular set? No. This one, it is not possible to say that element x belongs to one particular set as well as element x does not belong to that particular set. This is not possible. So that is a empty set. एक इलेमेंट एक्स त्या सेट मध्ये आहे पण आणि नाही पण, तर या दोन्ही कंडिशन एकाच वेळी कधी ट्रू असणार नाही. म्हणजे काय? दॅट इलेमेंट इज नॉट प्रेझेंट देअर. In fact, we can say that that set is empty, and that empty set is represented here by phi. Next term is a power set. So many questions are asked based on this power set. What is the formula? How to find the power set? So for a set A, collection or family of all subsets of A is called as power set of A. So collection of all the subsets of that particular set A is called as power set of A. The power set of A is denoted by P of A. So here this P stands for power set. So power set of A, or this can be represented as 2 raised to A. So this is the formula to find number of power set for that particular set, 2 raised to A. And here A is the that set, means what? Number of elements belongs to set A. So this power set of A, this is equals to 2 raised to A, this is equals to x, such that x is subset of A. Because what is the meaning of power set? It is collection of all the subsets. That's why we have written the power set like this. So first is power set of phi is set phi. Phi means what? Empty set. So its power set is set phi only. Second one, if your set S1 is consist of only one element and that element is A, then its power set will consist of how many elements? That is 2 raised to A, 2 raised to S1 here. So S1 is consist of only one element. That's why 2 raised to 1, and that is equals to 2. So power set of S1 will consist of 2 elements. First element is phi and second element is set A. So that is given here. So again this set A, we can replace this one by set S1, because here we have written S1 is equals to set A. So again we can write that set as phi comma S1. Now if your set is consist of 2 elements, so here we have taken set S2, which is consist of 2 elements A and B. Then its power set will consist of 2 raised to 2, that is equals to total 4 elements. So always keep in mind that first element of any power set is phi. So first element is phi here, second element is set A, third element is set B, and last element is set A comma B. Or we can write S2, because S2 is equals to set A comma B. Now again, if your set is consist of 3 elements, so here we have taken one example. S3 is consist of 3 elements A, B, C. So first of all, we have to find how many elements will be there in power set. That is 2 raised to 3 and that is equals to 8. So according to rule, the first element is always 5. So first element we have written here and that is equals to 5. Second one is set A. Next one set B. Then set C. Then set A comma B. Then set B comma C. Then set A comma C. And last one set A comma B comma C. So check here, count how many elements are there. 1, 2, 3, 4, 5, 6, 7 and 8. So if your set is consist of 3 elements, then its power set will include total 8 elements. So these are the some terms related to set and these are very important. So what we have seen, first term as a first term as a subset or we can say inclusion. Then second one equality. Then next term we have seen as a proper subset. The next one universal set. Then empty set and last term as a power set. These are the some terminologies related to set. So do you have any doubt up till now? Yes. Do you have any doubt regarding these terms? Okay. So next point is operations on sets. So this is also very important point. So what are the operations we can perform on set? So first operation is a intersection operation. So the intersection of any two sets A and B is written as A intersection B. Is this set which is consist of all the elements which belongs to both A and B. So this is a definition for intersection. So if you take any two sets A and B, then we can write the intersection of A and B, that is a set which is consist of elements those belongs to both A and B. So we can say that A intersection B will include common elements from set A and set B. So how we can represent it symbolically? That is A intersection B. This is equals to, for any element X, X belongs to A and X belongs to B. And this intersection will consist of set of all such elements. Those belongs to both the sets. So again here A intersection B, this is equals to B intersection A. This is correct. Again A intersection A, this is also equals to A. And last one A intersection 5, this is equals to 5. So why we have written here 5? Because 5 means what? Empty set. And your set will consist of, set A will consist of some elements. So again if you take intersection, its answer will be 5 only. That is empty set. So again here we have proved how we can say that A intersection B is equals to B intersection A. Now suppose your set A is consist of 3 elements 1, 2, 3 and set B is consist of elements 1 and 2. Now if you want to take intersection between these two sets, again we are looking for what are the common elements of set A and set B. So first set is having 1, 2, 3 and second set is having 1 and 2. So here we can say that 1 and 2, these are the common elements. Those belongs to both in set A as well as in set B. That's why A intersection B, its answer is set 1, 2. So likewise, again if you take B intersection A, you will get same answer, that set 1, 2. That's why these two terms are same. That is A intersection B, this is equals to B intersection A. So now how we can prove this? So consider one element X and X belongs to A intersection B. So first of all, we are going to replace this A intersection B by its definition. So the definition we have already seen the element X belongs to A and X belongs to B. So again, X belongs to, for any element X belongs to A. So this is equals to X belongs to A, and X belongs to, for any element X belongs to B. This is equals to X belongs to B. So again, this is a conjunction operation. So just like P conjunction Q, this is equals to Q conjunction P. So again here X belongs to A and X belongs to B. This is similar to X belongs to B and X belongs to A. So again we can write this one as, for any element X belongs to X such that X belongs to A and X belongs to B. Here this term we have written from definition of set. So this is equals to X belongs to B intersection A. Check here. X belongs to B and X belongs to A. This was common part of B and A, and that is represented by B intersection A. That's why A intersection B, this is equals to B intersection A. So again, if there are three terms, that is three sets A, B, C, then A intersection B intersection C, this is equals to A intersection B intersection C. So this is a associative property. So we can say that this intersection operation satisfies two properties, commutative property and associative property. So this is the first operation that we can perform on set, that is a intersection operation. So again there are many operations. Remaining operations are, I think, union operation is there, then symmetric difference is there, again relative complement is there. So again disjoint operation is there. So all those operations we will see next lecture. So do you have any doubt? The part we have covered today. If you don't have any doubt, then just give me presently. Roll number 1, only 33.
Yes,
In
ma'am.
short, 1 and 2, these two are of mine. Only 31 are present. Why your present is decreasing? Roll number 1,
Yes, ma'am.
2, 3.
Yes, ma'am.
Okay, just tell me your present roll numbers from 1 to 10. How many are present?
1,
1.
3, 4,
Second. 1 is present, 3 is present, 4 is present. Okay. Any another?
10,
Okay, 10. Now from 11 to 20,
11,
11,
13,
13,
15,
15,
20,
20,
18,
18. Now from 21 to 30.
21,
22,
Okay.
24.
25.
Hmm.
30.
30. Now from 31 to 40.
32.
Hmm.
33.
33.
36.
36.
37.
37.
38.
38.
40.
40. Okay.
29, ma'am.
29. Hmm.
36.
36. That is second. Now from 41 to 50.
46, ma'am.
Okay.
49, ma'am.
50.
50.
50. Or now 51 to 60. No one is there from 51 to 60.
57. 58.
Ma'am, 58.
Okay.
59.
59. Okay. From 61 to 70.
61.
Yes.
66.
63.
64.
63. 64. Or
57 घेतला.
yes, that is also taken. Okay, so today we are going to stop here. Thank you.